The sun, that gigantic ball of fire that lights up our days, emits sound. Did you know that? At first glance, this question may seem rather simple, especially if we think about our daily lives here on Earth. Most of us would quickly answer, of course not, the sun is mute. After all, we learn from an early age that sound needs a medium to propagate, and in a spatial vacuum, that would be impossible, right? But what if I told you that there was a way for sound to travel through space, across the millions of miles that separate us from our parent star? What would we hear? Would the sun give us a celestial symphony? Perhaps a melody as beautiful as it is frightening, capable of echoing through the cosmos? Or would it be an overwhelming sound, a kind of cosmic roar that, if we could hear it, might become the last thing to hit our eardrums? Thanks to advances in technology and the relentless efforts of scientists, we no longer have to rely solely on our imagination to explore these questions. Sophisticated space instruments, such as the Parker Solar Probe, which is currently orbiting close to the sun, offer us clues to this mystery. These probes pick up pressure waves and particles, sound traces from the sun, if you will, which give us an idea of what we might hear if the vacuum of space weren't an obstacle. But here's another fascinating detail. The sounds captured are not all the same. What we are hearing, through recreations made by specialists, is the transformation of these amplitudes and frequencies into something that our ear could understand if there were air there. Just imagine the sound diversity that this immense cosmic furnace is capable of producing. Our planet Earth is about 93 million miles away from the sun. That's pretty far, isn't it? Even so, scientists say that the sun is actually super noisy. Imagine a sound reminiscent of those humming electric generators, or even something you'd say was radioactive. This is all because inside the sun there's a gigantic nuclear party going on that produces an absurd amount of energy. To give you an idea, the sun produces more energy in a single second than the whole of humanity can produce in a year. That's a lot of energy. Now, if by magic we could hear the sound of the sun here on Earth, it would be like turning your cell phone up to the max on giant speakers, the kind used at rock concerts. And if you played the sound of the sun at a volume of 110 decibels, which is very loud, it would be unbearable. You wouldn't be able to listen for long without going deaf, not to mention the uproar it would cause, with everyone having to wear earplugs all the time so as not to lose their hearing from the noise coming from the sky. Now let's imagine that you're on a spaceship setting sail into the unknown, bound for the sun, that immense ball of fire that lights up our days and tans us in summer. But as you get closer, you notice something strange. It's not a constant hum you hear, but a variation. Something different, something alive. Are you curious to know what it is? We're talking about the solar wind, my friends. Oh, and don't be fooled by the name wind. It's nothing like you've ever felt on Earth. Imagine a flowing river of charged particles, a superheated plasma, exploding from the sun and traveling through space at breathtaking speed. This tireless stream of solar energy travels through the solar system, touching planets, stars, and maybe even visiting some aliens along the way. Think interplanetary express delivery. Now, if you think receiving lots of notifications on your cell phone is information overload, imagine what these particles are doing. And by the way, around 1 million tons of these particles are launched into space every second. That's right, per second. And this whole story gets even more interesting when the solar wind meets the Earth. It's the aurora borealis, those spectacular lights in the night sky of the polar regions. But what makes the sun expel such a powerful solar wind? It's all thanks to nuclear fusion, a force so powerful that it even overcomes the sun's gravity. Just imagine the energy needed to overcome this gravity and launch particles into space. In the 1960s, scientists discovered something incredible about the sun, our mother star. They realized that in the sun's atmosphere, which is called the corona, there were particles moving around. But not just any particles, they had a very peculiar speed pattern. Near the surface of the sun, these particles were moving at a speed of around 476 feet per second. Fast enough, right? But here comes the big surprise. When these particles left the corona and traveled into space, they accelerated wildly, reaching speeds of up to 2,027 feet per second. This means that these particles gained enormous energy to be able to move away from the sun and travel through space. Now, you might be asking yourself, but what makes these particles accelerate so much, from a normal speed to a super speed? Well, that's the question that has left scientists scratching their heads. To this day, the process by which the particles in the solar corona accelerate from subsonic to supersonic speed is a great mystery. Experts think that the sun's magnetic fields may be behind this heat fest in the corona. As we get closer, we come across a phenomenon that seems straight out of a science fiction movie. Tiny particles, called plasma, begin to vibrate. This vibration is caused by the sun's light, which pushes these particles through small funnels on the sun's surface. You can imagine it like the sound a kettle makes when water starts to boil, but on a cosmic scale. Now, here comes the even more interesting part. The winds in this region create waves, but these waves don't travel together in harmony. Some are faster, others are slower, and this causes them to spread out. This spreading out of the waves generates small whirlpools of sound, a kind of dance between the fast waves catching up with the slow ones. Eventually, this dance finds a rhythm, and it is this balanced sound that reaches us. These sounds are like short bursts, but as we venture closer to the sun, they change. Imagine a howling wind. This is where magnetic reconnection comes in, which, despite its technical and somewhat harmless name, is a real cosmic spectacle. Imagine magnetic field lines dancing around the sun, stretching and finally merging, as if they were celebrating a reunion after a long time. This magnetic embrace creates an explosion of energy, forming what we call a nano flare. What about this event? Well, it heats the corona to absurd temperatures. We're talking millions of degrees in a matter of seconds. Now, while the Parker probe continues its valiant journey around the sun, collecting precious data, the question remains: which of these sounds did you find most impressive?